Hello students, so today in this lecture I will tell you the use of thallium as a reagent in organic synthesis. So thallium as a thallium nitrate can be used as a reagent or as an oxidizing agent in organic synthesis. So thallium nitrate or thallium trinitrate can be used as an oxidizing agent in organic synthesis, or we can write in a short form TTN can be written as a short form. So some of the properties of this thallium trinitrate, one of the property that is it is very toxic in nature, and second one, this thallium trinitrate and it exists in +3 oxidation state here. So this thallium in +3 oxidation state is easily get reduced into +1 oxidation state. Okay, means it can gain 2 electron and easily get reduced +1 oxidation state because the reduction potential for this thallium trinitrate is very high, and it is around 1.2 reduction potential. So as it is having the +3 charge over it, so that's why it has very strong electrophilic center. So it has strong electrophilic center. It has strong electrophilic center, and a nucleophile can easily attack over this thallium trinitrate. Okay, another one of the point for this is that when during the organic reaction, when thallium carbon bond which is formed is very weak. So you will see it. This thallium carbon bond is very weak in nature. So it will easily get broken. Now next thing, that during the reaction you will see here 3 nitrate groups are present, 3 nitrate ions, or we can say 3 nitrate ions are present over here, and one of the nitrate ion during the reaction, during this oxidation reaction, one of this nitrate ion can act as a nucleophile intramolecularly. So nitrate ion, here this one of the nitrate ion is present. So if you will see O and O, or we can write suppose this O, okay, sorry. So this one of this nitrate ion can act as a nucleophile intramolecularly. So we will see this in the reaction. So one of the nitrate ion acts as nucleophile intramolecularly. Okay, now it can oxidize various organic reaction, or it can do the oxidation of alkenes, it can do the oxidation of suppose this cycloalkenes. Okay, then alkynes and cyclopropane. Then we can do the oxidation of this ketone, then alpha beta unsaturated ketone, esters, like this. So you will see the oxidation of these reactions and their mechanism one by one. So let's see first the oxidation of these alkenes. oxidation of alkenes. So suppose if we have alkene, suppose if we have an alkene, then so we have this thallium nitrate, how it oxidizes this one. So let's see. So it will act as this alkene molecule, it will act as a nucleophile, and it will attack over this electrophilic center. One of this nitrate ion will leave out. So what we will get? So positive charge will get generated over here. So I can write positive charge over here, and this thallium, and 2 NO3 over here. In next step, so this one of the positive charge over here. Now we have suppose methanol, or water can act as a nucleophile here, or some other nucleophile may be added over here. So this nucleophile and this H plus may be taken by this nitrate ion. So this nitrate ion will take this H plus, and what we will get? So we will get R here, this methoxy group will add over here, and so now what we can do, what I told you, this thallium carbon bond is a weak bond due to the large electronegativity difference. So this bond will get broken. And another molecule of this methanol can add over here. Okay, so this nitrate ion will grab this proton. Okay, will grab this proton, and finally what will leave out? We can say HNO3. HNO3 here also, one of the HNO3 will leave out, and another thallium nitrate having this plus charge. So here, as you can see, the thallium which is present in +3 oxidation state is now converted into +1 oxidation state. So here it has +1 oxidation state, and now so another methoxy group is added over here. Okay, so like this. So now in next step, if we do the hydrolysis, so hydrolysis of this can be done, and what we will get? We will get OH over here, or one of the OH diol can be. Okay. So like this. So this is the one of the product, and now in next or otherwise another reaction that we can write. What I told you, it involves the it involves the 1,2 shift also. So during this oxidation reaction, 1,2 shift may also occur. So suppose if we have this part, suppose if we have here, so how this 1,2 shift may occur. So let's see the another. So this is one of the product. So this is one of the product. Suppose this product is 1. Now if you will see, then what I have written. So in this thallium trinitrate and in presence of methanol, suppose I am writing this product directly here. So if we have thallium trinitrate and this methanol, then what I have got? This product. So R O N E . Now in next step, what may happen? In next step, so suppose if we have another molecule of methanol, then what can the another step, as this will leave out this bond will get broken, and here this 1,2 shift may also occur. 1,2 alkyl shift, 1,2 alkyl shift. So 1,2 alkyl shift. So this will from first position to the second position. The alkyl can shift from first position to the second position. So what we have got? We have got this OMe, okay, and OMe, and the next here I have got this R. So this is R, and here we have generated the positive center. So in next step, another molecule of this methanol, it will tap over here, okay, OMe, and this is OMe. So now we can do the hydrolysis. After hydrolysis, so what we will get after hydrolysis? OH, and finally we will get aldehyde also. This may be the another product here. So this is one of the product that we may get, and this is the next product after 1,2 alkyl shift. Now let's see the next reaction. So this is, suppose this is reaction number first, and if we see the next reaction, now suppose if we have another alkene molecule, so what should be the product here? What should the product? So if we have this thallium trinitrate, and then methanol, and then we have hydrolysis. Okay, so what would be the product? So if we see this one, then let's see the mechanism. So how we can write it? So this will act as a nucleophile. We have thallium trinitrate. We have thallium trinitrate, ONO2. So this will, one of the NO2, this will leave out, and we will have single bond over here, and this is R3, R4, and thallium. Okay, so in next step, what I told you, this carbon thallium bond, this will break. So this will break, carbon thallium bond will break, and another, this will leave out, and now this can the 1,2 again 1,2 alkyl shift, 1,2 alkyl shift may occur, 1,2 alkyl shift, and we have nitrate ion minus thallium, nitrate in +1 oxidation state. Okay, so like this. So what will be the product over here? The product is, this is your R2, this is R3, this is R4, and we have R1 and plus charge over here. Now the methanol as a nucleophile will attack over this center, and what we will get? So this nitrate ion, this can grab this proton, and what we will see? R2, R3 and R4, and finally after this hydrolysis, Okay, so this may be the product here. In this case, this will be the product. Okay, so now let's see the reaction of cycloalkene. Let's see the reaction for cycloalkene. So if we have, let's take example of the cycloalkene. Now this. So how it will, the thallium nitrate will get oxidized? We oxidize it, thallium nitrate. Okay. Now next step. In next step, we have positive charge over here and this thallium, so one of this NO3 nitrate ion will leave out, and we have two nitrate ion which are present over here, two nitrate ion. Okay, like this. Now in next step, shift 1 to alkyl shift. So in next step, 1 to alkyl shift may occur. So how the alkyl shift? We can show the alkyl shift. So positive charge. Now suppose if we have one of the methanol molecules. So first of all, this methanol may attack over here. Okay. So we have this nitrate ion will take this proton and methoxy group will add over here. Okay. Now what I told you, this carbon and thallium bond is the weak bond. So it will break. So when this will break, suppose I break this one, suppose I break this one, so this will leave out. Now one of the center, this positive center is created over here. So now this 1 to alkyl shift, so this bond will get broken and it can attack this one. So this electrons will go into the anti-bonding orbital which is present over here. Or otherwise we may write in this way also. We may write in a chair form. If you want to write in a chair form, suppose I write it in a chair form. So one of this group O and O2, and we have this O and E. Okay, so what we have to do, we have to break this carbon thallium bond. This will leave out. Okay, this will leave out. So what will, so their positive charge, positive center is created over here. A positive center is created over here. Now this, the bond, this bond, the electrons of this bond will go into the anti-bonding orbitals of here. Okay, this will attack over the, this will go into the anti-bonding orbital. So either we can show in this way or here like this. So what we can write, so this 6-membered ring here, this 6-membered ring, that would be converted into 5-membered ring. So either, so this is equivalent to this. So either we can write, so means this bond has broken, this bond has broken, and O and E. So positive charge will create at this center. So positive charge will create at this center. Now this positive charge, okay, so here we have a positive charge, and what we will get? We will get OMe. Okay, and so positive charge, the positive charge will create at this center. The positive charge will create at this center, this one, this here the positive charge will get created. So this is a positive charge and this is converted into 5-membered ring. In the same way we can understand this one also. Suppose I write or this can be written in a chair form. This chair form is 6-membered ring, this chair form, that would be now converted into 5-membered. So if I write it like this, okay, so which bond I have broken? This bond has broken and this will get attached to this one. Okay. Now finally the positive charge will create at this center. The positive charge will create at this center. So I will join this center and this center. I will join this center and this center. Suppose this, I have joined this center and this center. Okay, so this is the new bond which is formed. This is the new bond which is formed, and this is envelope. This is like the envelope form, this chair form, then this is 5-membered envelope form, and here this is the next one is your, and here we have the positive charge, and this is OMe. Clear? So what we have left out, NO3, one of the NO3 is left out, and thallium nitrate in +1 oxidation state, that is left out. Okay, so this is the structure. Now, so this can also be written like this. This can also be written in the 5-membered way. This is the another way of representation. Now, in next we have another methanol molecule which can attack over this center, and this nitrate ion will grab this proton and it will attack over the center, and what we will get OMe or appendix methoxy, and finally we can do the hydrolysis. And like this. So this would be the product. Okay, this will be the product. So let's take the another example. Let's take next example. So suppose if we have now suppose what should be the oxidation product of this one? What would be the oxidation product of this one? So if you will see, then first of all we have thallium nitrate, okay. So the positive charge, here we will have the positive charge. Okay, so in the next step we have ONe, nitrate ion. This will take this one, this will tap over this center, electrophilic center, and now in next step what will happen? again this 1-2 shift, the 1-2 shift will occur. What I told you, this bond is the weak bond, this bond is weak bond. Now this bond will go over here, this bond will go over here, and what we will get here, 5-membered ring that can be formed. We can have the 5-membered ring. So 5-membered ring, and so we will have O and E, positive charge over here that will be created. Clear? So means minus, similar to the previous question, Okay, now another methanol molecule. So this nitrate ion, NO3 minus, this will take this one and this will attack over here, and we will get the O and E. And now after this hydrolysis we will get the so this would be the product. Okay, so this would be the product in this case. So this is about the cycloalkene. Now let's see the reaction for alkynes. So let's see the oxidation of alkynes. Reaction of alkynes. Okay.